My name is Casey Lowe, and for my creative project I decided to come up with the idea of explaining to you in a thermodynamic sense of how steam is produced in an open shower system of a stand-up shower with an opening kind of like this one right here versus a closed shower system, which also is shown right here with this little window covering shade that I've put together here to close off the top of the shower. And in this explanation, I will be representing how both an open and closed shower system will work, as well as explain which system would be more beneficial when you're showering and more energy efficient, and which would keep steam in and release steam and also increase the temperature of the water at the same temperature as the shower itself. So I have a diagram right here that I'm going to show you. But first, just to represent temperature change, in this room right now, it's a little chilly, but I have this thermometer right here, and it says inside right now it is 62.4 degrees, a little bit cold, but now I'm going to put this thermometer right here inside the shower, here, and then I'm going to turn on the water, and like I said, let me shut the door. Like I said before, I constructed this little bit out of the ordinary window shade with a rug, and just to kind of keep, and a little bit of duct tape here, just to kind of keep the steam inside whenever the water gets hot. Now, let me just put this down for 1 second. I'm going to set this down just for 1 second. I'm going to duct tape this together here. Just to show you what I just did, I just duct taped that door opening closed so then none of the steam would get out. Alright, so just to recap, I put up my thermometer in there. It was 62.4 degrees to start, and I'm going to write that down right here in my diagram. I can find my pen. There it is. Okay. Got my diagram here, my open and closed shower system. So start temp equals 62.4. This is with a closed system. Like I said right there, I got my vents shut right here. So just to explain to you a little bit more about this system, like I said, whenever you're thinking about a open shower versus a closed shower system, the first thing we should think about is how the steam is created when taking a shower into account and the water coming out of the pipes and heating it up and everything. So in a thermodynamic sense, there is hot water that is exiting the shower head, and this water is entering into a colder space, just kind of like I represented right here with the open shower system. This is mostly what everybody has. And if you're like me, when you get up in the morning, you want to turn on your shower to get it warmer. And so just to get past that and to solve that problem, you have this closed shower system with a vent right here, which is closed off, and it becomes easier for the temperature of the shower to get closer to that of the water temperature. But just to get back to the open shower system, this water here is coming out of the shower head, the hot water, the Q right here, the Q is going in, the heat. And this shower, since it's open, the cold ambient air is entering into here. And, I'm sorry, I'm not videoing this very well. And as the water's coming down, it's producing steam. So, say this hot water is around 100 degrees Fahrenheit, and the hot water has a higher vapor pressure than the room temperature water. And these water molecules will evaporate when they enter into the ambient air. At least some of them will. This is what the steam is. When the water vapor hits the colder air, right here, this water hitting the colder air, it will condense. Condensation will be taking place, and the steam, which is more like fog, suspended like water particles in the air, will come about into the shower, and this steam, which is more like fog. When you think about the thermodynamics and the heat change, the higher the temperature of the water coming out of the shower head, the higher the pressure it puts out. In other words, the hot liquid shower water exerts a certain partial pressure of gas, right here, the steam moisture coming out of the shower from the water because it's open, and it's mixing in with that cold air. So this cold air and this heat mixes together and it exerts this steam moisture. And that hot liquid shower water exerts a certain partial pressure of gaseous water upon itself, and as this hot water enters into the colder air coming out of the shower head, the more of that water will turn into a gas and lower the equilibrium partial pressure. So, that last part I was talking about, that's in an open shower system. The equilibrium partial pressure of the water will be lowered and not be going towards equilibrium as it would in a closed shower system. This would also decrease the temperature and not, you would still have that cold ambient air going through it back and forth. So, trying to represent this as best I can with this video, but like I put here, the cold exterior air plus the warm shower water equals the production of steam into the atmosphere, which is the condensation of the water molecules, and more water will evaporate due to the ambient air. So now we have a starting temperature of 62.4 degrees, and let's look back at the shower right now. We've been had the shower water on for about 6 minutes now, and you can tell that all the steam, or relatively most of the steam due to my design here, kind of a prototype, is most of this steam is locked into the shower right now, and soon I'm going to open the door in about a minute, and I'm going to show you the release of the steam, and we'll check the temperature to see how hot it is in there. And but until then, I'm going to go back to my diagram here, and I'm just going to talk a little bit about the benefits of having an enclosed shower. And that's mainly the fact that it would be, it would obviously retain more heat and not have that constant flow of the cold ambient air right here coming through it. So you're standing in here, you're taking a shower, you got that cold air running up and down your body, and it kind of goes back and forth. I know you guys have that feeling. That you get that cold, shivery feeling, and then you'll get the hot air, and the steam will go all around you, and then it kind of exerts into the atmosphere, into the bathroom itself, and that's what causes the foggy mirrors and all that stuff. So with this closed system, the enclosure would trap all the steam from the hot water, and it would heat up the shower stall much faster. And like I said, I know most of you wouldn't want to be cold, so preheating your shower wouldn't really be necessary if you had this closed system. It's also that option of having this vent right here, which is mainly needed. The steam generated vent you can install to and it would dispose the majority of the steam, yet still keep the same temperature level as the shower and the water coming out. So this Q right here, this heat, would stay the same temperature, and it would increase as the water continues to fall in there. So it's in my opinion, this would be a way better design and option to have in a shower system, because it wouldn't take as much heat, and it would be way more comfortable for someone. Also, just to be clear, we're talking about the steam production here in a closed system, open system shower. And in the closed shower, it would be much more minimal than an open shower, because there could be much less cooler air mixing in right here. None of that here. Mixing in with the shower water. For this system to work properly, the work needs to be put into a vent, installed into the top to release the condensation produced. That's right here. Condensation would go out through here, the steam, but it would still keep the same temperature, and the temperature would increasingly get warmer to close to that of the water temperature of the shower. I'm sorry. Excuse me. Let me repeat that. The shower temperature itself before the water would increase to the point of the water coming out of the shower head, and that would also increase the equilibrium of the partial pressure of the water and the heat. So let's look down here at these little notes I have. Like I said, this vent disposes the majority of the steam while still creating a higher temp closer to that of the water temperature. This vent will release the condensation produced, but not the heat. So this is obviously a better system, and I thought it would be a good idea. I thought of it in the shower actually, and this just kind of explains a little bit of the thermodynamics of the heat exchange of the cold air with the hot water. And now we're going to go back to this shower right here. Sorry, this video is a little longer than anticipated, but now we're going to open the shower door. And as you can see, the steam is pouring out right here. All this steam in an open system would have already fogged up these mirrors. And you can see it's kind of getting foggy already. But with that vent put right here, take off this tape, open up this a little bit, open that up a little bit. You can kind of, tell, if we close this back. This is obviously not a vent, but it's just a representation. You would have a vent up there, and that vent would kind of let out the steam, but it would also keep the same temperature in here. Now we're going to shut off this water right here. We've wasted enough water. We're going to take a look at this. Take a look at this temperature gauge here. Looks like the temperature is increased by about 15 degrees. It looks like 62.4 was the starting number, and we increased to about 77.4 within 8 or 9 minutes. So you do the math, but just to give you guys, just for time's sake and to save time on this video, if you ever think about wanting to put a thermometer in your shower and make some sort of rig like I have right here, if you want to compare the open versus closed system to see which would be better for you and which would be more ideal for heating your body in the shower and feel more comfortable, you can definitely do that. Get myself back around. Just want to say I hope you guys enjoyed my video, and this is, by the way, this is my parents' bathroom. I decided to do this over Thanksgiving, so anyway, I hope you enjoyed my video and learned a lot from it, and enjoyed my creativity. Anyways, thank you and have a great day.